Hello guys, in this video we are going to discuss the solution of the problem search in rotated sorted array. So let us look at the problem statement. The problem statement says given a sorted array ARR of distinct elements which may be rotated at some point and given an element key, the task is to find the index of the given element key in the array. The whole array ARR is given as the range to search. So for instance, if you see, this is an rotated sorted array which is rotated at this point. So 1 to 3 is sorted and 5 to 10 is sorted. Given this array and a key is given to us which is 10, we need to return its index. So since 10 is at index 5, so we are returning 5 over here. If the key is not to be found in the array, then in such case we are returning -1. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is applying binary search. Now since the array is sorted but it is rotated also, because of which we have to tweak binary search logic. And the modification which we are going to do over here is, so as we know in a binary search we will have 3 pointers: a start pointer, mid pointer and end pointer. So these 3 pointers are there with us. Now with these 3 pointers, we can divide the array into 2 parts. So let us say this is my array and this is our start pointer, this is our mid pointer and this is our end pointer. Now with these 3 points, we have divided the array into 2 parts. So this is my first part and this is my second part. So let us write it down. So this is my first part and this is the second part. Now since the array is sorted and rotated, because of which either first part will be sorted or the second part will be sorted. What do I mean by this is, let us take an example. So let us say the array which is given to us is this. So this is the array which is sorted and rotated, which is given to us. Now the mid position for this array will be this element. Now as you can see, with this element the array got divided into 2 parts. So this is my first part and this is our second part. Now out of these 2 parts, as you can see over here, the first part is sorted. So that is what I am trying to say over here is, if we have an array with us and with these 3 pointers which is start, mid and end, either the first part will be sorted or the second part will be sorted. Now with these 2 concepts, that either the first or the second part is sorted, we can search the element quite easily. So if the first part is sorted, then in such case ARR start will be less than ARR mid, since the array is sorted in ascending order, because of which if the first part is sorted, then this condition holds. Otherwise this condition will fail, because of which we realize that the second part of the array is sorted. So over here first part is sorted if this condition holds, and if this condition fails, that simply means that the second part is sorted. So let us discuss the case where the first part is sorted and let us see how we will be able to find key within the array. So it might be possible that the first part is sorted and key lies within the first part itself. So that simply means key will be less than AR mid and key will be greater than or equals to ARR start. And in this way, we are sure that the key lies within the first part of the array. Now, since the key lies within the first part of the array, so the search also has to happen within the first part of the array, because of which we are going to update our end pointer, and the end pointer will be updated as end equals to mid -1. Otherwise, if the first part of the array is sorted and key does not lie within the first part, then that simply means the key lies within the second part, and we are going to search the element in the second part, which simply means start equals to mid +1. Similarly, if the second part is sorted, then we are going to check whether the key lies in the second part or not. So if key is greater than ARR mid and key is less than or equals to ARR end, then in such case we are sure that the key lies within the second part of the array between mid to end. And in such case, all we have to do is update our start pointer. So the start will be equals to mid plus 1. And if the second part is sorted and the key does not lie in the second part, then that simply means that the key lies in the first part and we will be searching key in the second part. So for such case, else we have to update our end pointer, and end will be equals to mid minus 1. And in this way, we will be able to search an element in an sorted rotated array. So let us take some example in order to understand this. So let us say this is the array which is given to us and these are the indexes. So to begin with, we'll have a start pointer and we are going to initialize the start equals to 0 and we are going to initialize end pointer with 8. Now let us compute mid. So mid will be equals to mid of this. So the mid position for now will be 4. So the first thing we will check is whether the mid is equals to key. So let us say the key to be searched over here is 5. So we are searching for key which is equals to 5. Now as we can see, ARR mid, which is here, is not equals to key. So now we have to see in which part of the array we are going to search the key. So with the help of start, end and mid pointer, we have divided the array into two parts, which is first part and the second part. Now, as we can see that the first part over here is sorted. So 5 to 8 is sorted, but 10 to 3 is not sorted. Now, since 5 to 8 is sorted, then let us see if the key lies within this range or not. So in this example, the key is in the first part of the array. So because of which we are going to update our end pointer and we are going to set our end pointer to 4. Now again, we will compute mid. So mid in this case will be 2. So let us have a pointer on 2 now. So we are here. Again, the array got divided into two parts, which is this part and this part. And since ARR mid is not equals to key, then we are going to search the element in either in the first part or in the second part. Now with our logic, we understand that the key belongs in the first part, because of which we are going to update our end pointer. So let us update our end pointer. So the end pointer in this case will be 1. Now again, we will go ahead and compute mid pointer. So in this case, the mid pointer will be 0. And once mid becomes equals to 0, we will be able to find our key, in which case we are going to return mid. Let us take the same example one more time, and in this case we would like to search for element 10. So let us take the same example. So let us say this is the array which is given to us and the element which we are searching for is 10. Now as usual, we will have a start pointer which will be 0 and an end pointer which will be equals to 8 and a mid pointer, and mid will be equals to 4. So the mid pointer is here, and on this ground we have divided the array into two parts. We realize that the first part of the array is sorted here. So this is the first part and the first part of array is sorted, but the key does not lie within this range, because of which we will be searching the element in the second part of the array. Because of which we are going to update our start pointer and the start will now point to 5. Let us compute our mid again. So in this case, the mid will be equals to 6. So our mid in this case is here, and with this mid we have again divided the array into two parts. So this is my first part which just contains one element, and this is the second part. Now as we can see, the second part over here is sorted and the first part is not sorted. So in the second part, we try to find the element and we realize that the element or the key is not to be there in the second part, because of which we are going to search our element in the first part, because of which we are going to update our end pointer to 5. And let us compute our mid pointer. So the mid will be also equals to 5, and in this way we have found our element and we are going to return 5 for this case. So I hope by now we have understood the logic behind the solving this problem. So let us take one more example in order to discuss a corner case. So let us say the array which is given to us is this, and the element to be searched over here is 1. So again, we have a start pointer 0 and end pointer which is equals to 4, and mid we have computed, and mid will be equals to 2. So mid is here. So as we can see, the first part over here is sorted, but the key is not there in the first part, because of which we are going to search the element in the second part. So let us update our start pointer, and the start pointer will now point to 3. So let us update our mid also. So in this case, the mid will be equals to 3. So in this case, start and mid is here, and the end pointer is here. So now let us check whether the first part is sorted or the second part is sorted. Over here, there is no first part because start and mid are at the same position, because of which our condition will fail and we will assume that the second part is sorted. And within the second part, the way we were checking whether the key is within the range of second part or not is something like this, where if key is greater than ARR mid and key is less than or equals to ARR end. So let us apply this logic. So the first condition is if key is greater than ARR mid. Now since this condition fails, because of which we are going to search for key in the first part of the array, which clearly will not give us the right solution, right? Because the key lies in the second part. So how do we tackle such case? Well, in order to tackle such case, what we are going to do is we are going to check if start plus 1 equals to end. So that simply means we are checking whether the number of elements between start to end is just 2. If the number of elements between start to end is 2, then in such case, rather than going through the binary search logic, we are just going to check whether ARR start equals to key. If this is the case, then we are going to return start. Otherwise, we are going to check if ARR end equals to key. If that is the case, then we are going to return end. And please note guys, this case we will use only if there exist only 2 elements between start to end. So that's the discussion of the solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to search an element in an array. So search function is there, ARR is given to us, and an element is given to us. So the first thing which we are going to do is we are going to initialize start equals to 0 and end equals to len of array minus 1. And then we are going to iterate on the array while start is less than or equals to end. Then let us compute our mid. So mid will be equals to start plus end minus start divided by 2. Once we have this mid with us, we are going to check if ARR mid equals to key. If this is the key, then we will simply go ahead and return mid. Otherwise, let us check for the corner case, and the corner case, as we discussed, s plus 1 equals to end, which simply means between start to end there exist just 2 elements. If that is the case, let us check if ARR start equals to key. If that is the case, return s. Otherwise, let us check if ARR end equals to key. If that is the case, then we are going to return end. Otherwise, we will apply the binary search logic we have discussed, which is first let us check which part of the array is sorted. So if the first part of array is sorted, then ARRS will be less than ARR mid. Now if the first part of array is sorted, now let us check whether key belongs in the first part of the array or not. So if key is there in the first part of the array, then key will be less than ARR mid and key will be greater than or equals to ARR start. In such case, we just have to update our end pointer, and end will be equals to start minus 1. Otherwise, the key belongs in the second part, because of which we will update our start pointer, and start will be equals to mid plus 1. Sorry guys, this will be mid minus 1. So if the first part of the array is not sorted, then that simply means that the second part of the array is sorted. Now if the second part of the array is sorted, So let us first check whether key is there in the second part or not. So if key is greater than ARR mid and key is less than or equals to ARR end, then that simply means key is there in the second part of the array, because of which we just have to update our start pointer and start will be equals to mid plus 1. Otherwise, the key is there in the first half, because of which our end pointer will be updated as end equals to mid minus 1. And in this way, we will be able to search key within the array. And let us say if we are not able to find the element, then in such case, we will simply return -1, indicating that the element does not exist in the array. And that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. So in the Python implementation, we have a start pointer and an end pointer. Then we are iterating on the array while start is less than or equals to end. Then the first thing which we did is we have computed our mid pointer. If ARR mid equals to key, then we are returning mid. Otherwise, we are checking whether we are in the corner case, which simply means end equals to start plus 1. If end equals to start plus 1, then we are checking the start and the end element to see whether ARR start equals to key or ARR end equals to key. If one of these conditions are satisfied, then we are returning either start or end. Otherwise, we are performing the binary search operation, which is the first thing which we are ensuring is whether the first part of the array is sorted or not. If the first part of the array is sorted, then we are checking the element in the first part. And if the key is there in the first part, then we are updating our end pointer. Otherwise, we are updating our start pointer. Similarly, if the second part is sorted, then we are checking whether the key belongs in the second part. If key belongs in the second part, then we are updating our start pointer. Otherwise, we are updating our end pointer. And towards the end, we are returning -1, indicating that the key does not exist in the array. So that's the code, folks. Now let us submit our solution. So our Python solution got accepted. Let us look at the C++ solution. So the C++ solution is the same, folks. Over here, again, we have a start and an end pointer. And we are iterating on the array while start is less than or equals to end. Then we are computing a mid pointer. Then we are checking whether mid equals to key. In such case, we are returning mid. Otherwise, the corner case. And if ARR start equals to key, then we are returning start. Otherwise, if ARR end equals to key, then we are returning end. Otherwise, we are performing the binary search logic and we are updating our start or end pointer appropriately. And towards the end, if we are not able to find the element, then we are returning -1. So that's the C++ code, folks. Now let us submit our solution. So our C++ solution also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.